Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Ilmi Wahyuni. On this occasion, we are going to learn about chemical bonding and molecular polarity in everyday life. Have you ever wondered why oil and water cannot mix? Or why alcohol dissolves easily in the water? These simple phenomena in our daily lives are closely related to chemical bonding and molecular polarity. Therefore, in today's lesson, we will discuss how atoms interact with one another and how this interaction influences the properties substance. Before we move further into the discussion, let us first review the learning objective of today's lesson. The learning objective of today's lesson are to explain how atoms form chemical bonds, to identify polar and nonpolar compounds, to relate molecular polarity to phenomena in everyday life. Now that we have understood the learning objective, let us begin with a fundamental question. Why do atoms form bonds? Atoms naturally tend to achieve a more stable condition with a lower energy. In chemistry, stability is closely related to electron configuration. An atom is considered stable when its electron configuration resembles that of a noble gas, in which the valence shell is completely filled. Atoms tend to achieve a stable electron configuration, which are commonly explained through the duet and octet rules. The duet rules applies to atoms that become stable with two valence electrons, such as helium. Meanwhile, the octet rule applies to atoms that tend to achieve 8 valence electrons, similar to other noble gases such as neon and argon. So, how do atoms achieve a stable condition? Today's lesson, we will discuss two main ways atoms achieve stability. The first is electron transport. In this process, one atom loses electron with another atom gains electrons. For example, in the formation sodium chloride, sodium releases one electron, while chlorine accepts one electron. This electron transport produces oppositely charged ions that attract one another and form an ionic bond. The second way is through sharing electron. For example, in the formation of water molecule, hydrogen and oxygen share electron to achieve stability. In the interaction formed through electron sharing is called covalent bond. However, electrons are not always shared equally between atoms. This difference in electron distribution is closely related to electronegativity and molecular polarity. Each atom has a different ability to attract electrons. This ability is known as electronegativity. Imagine it as a tug of war electrons. Some atoms attract electrons more strongly than others. For example, in water molecule, oxygen attracts electrons more strongly than hydrogen, causing the electron density to become greater around the oxygen atom. As a result, the charge distribution within the molecule becomes uneven. The oxygen side becomes slightly negatively charged, while the hydrogen side becomes slightly positively charged. Therefore, water classifies as a polar molecule. In contrast, white carbon dioxide has a symmetrical molecular shape. Although oxygen attracts electrons strongly, the electron distribution becomes balanced. This because the bond polarities cancel each other out. As a result, carbon dioxide is classified a nonpolar molecule. So, molecular shape also affects molecular polarity. Now, let us analyze the following molecules. Based on their molecular shape and electron distribution, do you think nitrogen trihydrate is polar or nonpolar? What about carbon tetrahydride? To answer this question, let us compare the characteristics of polar and nonpolar compound. The first, based on electron distribution. A polar compound have uneven distribution electron. In contrast, nonpolar compounds have a more even electron distribution. Next, based on molecular shape, polar molecules usually have asymmetrical shape. Meanwhile, nonpolar molecules tend to have symmetrical shape. In some polar molecules, lone pair on the central atom also contribute to the uneven distribution of charge. For example, nitrogen trihydrate have a lone pair and asymmetrical shape, make this in molecular polar. On the other hand, carbon tetrahydride has a symmetrical tetrahedral shape, causing the electron distribution to remain balanced. Therefore, carbon tetrahydride is classified as a nonpolar molecule. From this comparison, we can conclude that both electronegativity and molecular shape influence molecular polarity. Now, let us see how molecular polarity influences substances in everyday life. One example of molecular polarity in everyday life can be found in soap. Soap is able to remove oil because contain both a polar and nonpolar part. The nonpolar part interacts with oil, and while the polar part interacts with water. As a result, oil can be leavened and mixed with water during washing process. Another example is alcohol, which dissolves easily in the water because both substances are polar. From this example, we can see the molecular polarity plays an important role in many aspects of everyday life. Now, let us summarize what we have learned today. Atoms form chemical bonds to achieve a more stable condition. Each atom has a different ability to attract electrons. This difference led to uneven charge distribution and molecular polarity. Molecular polarity influences various phenomena in everyday life. At the beginning of the lesson, we discussed why oil and water do not mix. Now, we understand that this happens because water is polar while oil is mostly non-polar. Chemistry allows us to understand invisible interactions that happen around us every day. Thank you for your attention and see you next lesson.